let's see, we talked about just bringing things straight in, talk about timing and pitch adjustments, finding the key, drum rack, simpler, sampler. Next is wavetable. And I won't go way in depth on wavetable synthesis, but I do want to give you an overview and show you how it worked with this sound. But this is going to be applicable knowledge for like this type of synthesis. So just overall, how does it work? A wavetable is just this list of waveforms, and they can be basic waveforms like sine waves, square waves, or in this case, the wavetable is made up of an audio sample that we just dropped on it. That means that every single one of these little lines is one tiny piece of the audio sample of Tilda's voice, Matilda's voice. I always want to call you Tilda because of your artist name. So they're all just stacked up. Here are two different views of the same thing, but it's just a bunch of little pieces of her voice stacked up. And this point right here is called an index, and it moves through the table of waves, which you can do in time so that the sound morphs over time. So looking at the most basic thing, oh, it's pretty low, like volume. This sound is the index moving up through the table of waves. And the way that it works is those waves will just repeat as time progresses. So that's how you get the actual continuous sound. And you can kind of hear the vocal quality to it when it's just moving up the stack, because it is putting together pieces of what was originally her voice, but it's cycling them. So it kind of just makes its own new sound. It's this new electronic sound that is kind of like the voice, but kind of different because the actual makeup of, if you were to take a longer sample of it, is different than if it's just her voice. But it is made out of waveforms that came from her voice. So that is what it sounds like. We have two oscillators here. So I took two different segments of her vocal sample and threw them in here. So you can see that we have a different table for each oscillator. Now, oscillators, just super quick recap, they're just the thing that produces a sound. So in this case, they're just the thing that keeps repeating whatever way you tell it to. So we have two of them going at the same time. And we have two filters here. Now, these filters, just to reinforce how you're going to want to just get to know the basics, and they're going to be the same everywhere. They also have different circuit types, different shape types, and the circuit type might be specific to Ableton. The shape and the rest of it is pretty much universal. So this one is a low pass, high cut filter, and this is the opposite. This control here, it tells this instrument whether to send, let's say if it's serial, then oscillator 1 and oscillator 2 go through filter 1 and then filter 2. Parallel is oscillator 1 goes through one filter and oscillator 2 goes through the other filter. And then, actually, I'm sorry, that's what split is. And parallel is that both oscillators go through both filters at the same time. So that's what I have this set on. So we have set up two filters here. We told both of the oscillators to go through both filters. And then the thing about wavetable synths that really makes them interesting and different than subtractive and FM synthesizers is that you can tell it how to change different parameters over time. So when we looked at the example of moving this index, that's the most important, that's the most unique thing about them. So if I wanted this thing to go travel up and down our source while time progresses, I can hook something up to that as an input. It can be anything over here that I want it to be. I decided to make it be an LFO. So we're moving on to the third panel of this instrument, and this is your matrix. So now we're in the matrix, and basically I set up one LFO to control the position in the first wavetable in oscillator 1, and then another LFO to control the position in the second waveform in LFO, or sorry, in oscillator 2. So that's how we end up with the sound here. Which that one's really low. This is a little more. You can still hear the vocal quality to it, but what we did is we actually made it into more of a texture. Okay, so as you can imagine, this opens up a lot of possibilities because you can take that vocal sample, you can do whatever you want to at first, like if you want to pitch it up, pitch it down, and then drop it on here and use it as your source for waveforms. And then you decide how fast. Oh, also, sorry, but I got to show you this cool thing. This is the only instrument in Ableton that does this, but you can make it take up the whole screen and see everything at once. So you can watch both LFOs moving both oscillators at the same time. Anyway, I just love that. I think all instruments should do that. All like virtual synthesizers should let you just open them up and do everything all at once because it's amazing. But this just opens up more possibilities. So think back to like all the sources that we talked about. You can get sound from anywhere. And then you can change it by, EQing it, warping it, pitching it, and then you can either sculpt that into an instrument, you can slice it into an instrument, or you can really just like dissect it down to the level of waveforms and then make it into a texture.